Hello everyone, I am ATUL NEGI and I welcome you all to IMS Academy YouTube platform. So we have started our foundation course on theory of machine and this is the topic flywheel we are going to discuss today, right? Basic introductory part regarding the flywheel we have discussed. In the last session we have solved some numericals also, right? So in this particular session we will be solving other GATE previous year questions related to flywheel. Okay, so fundamental part which is required to solve any flywheel numerical, we have already discussed how to calculate work done per cycle, how to calculate mean torque, right? So all those parameters we have discussed. What is the fluctuation of energy? Okay, so that formula also we have derived in the last class. I hope everyone has understood the complete basic fundamental part of the flywheel, right? So starting with the flywheel GATE problems will be discussed today in this particular session, right? Now before starting the lecture, guys, please join this Telegram group. Link is given already in the description and also link is provided here, where you will be getting all the quizzes which is important for your GATE examination. All the quizzes will help you to prepare for the competitive examinations like GATE, AE and JEE examinations. Apart from that, you will be getting all lecture PDF that we are taking in YouTube channels. Okay, whatever the YouTube events that we are going to conduct, all informations you are getting in this Telegram group. Audible? Thank you, Matan. Right, and all latest job notifications you will be getting in this particular Telegram group. So I will advise you to join this Telegram group. And IMS GATE Academy live online program is there. You can join this program for your GATE preparation. And most important feature of this program is that live classes are totally interactive. In the live class itself, you can discuss your doubts. Okay, you can discuss your doubts in the live class itself. Okay, and apart from that, mentorship sessions will be there, which is one-to-one sessions, where you can directly connect with the faculty and discuss whatever the challenges and the problem you are facing in your GATE preparation. If I talk about the study material, GATE question bank, you will be getting exercise in the theory book for every subject. Online support, whether it is a doubt solving support or online test series, everything you will be getting in this live online program. So new batches will be starting from the next week. So if you are interested in the live online program for the GATE preparation, you can directly call on these numbers and our counseling team will help you to enroll in this program, right? So let's get started with the today's session. And we'll start with the numericals on the flywheel, right? So in the last class I've given you this homework. Okay, this was the question for homework I've given. As a homework I've given this numerical, right? So I hope all of you have solved this question. If you have solved this question, so please mention your answer in the live chat box. Please mention your answer in the chat box, guys, if you have solved this question. I've discussed how to approach this kind of problems. Okay. Now, if you go through with this problem here, they have mentioned a torque exerted on the crankshaft of two-stroke engine described as like this. So they have given this torque expression where theta is the crank angle. Now, assuming the resisting torque to be constant, the power developed by the engine at 100 rpm. So the point here is they are asking the power developed. Right, power they are asking, and if I write the formula for the power is mean torque multiplied by omega. Omega, they have given the omega at which we need to calculate the power, but main point is how you will calculate this mean torque. Okay, for that we have discussed the relations work done per cycle divided by the time period. You will get the mean torque. How you will get the work done per cycle? Just integrate T d theta, you will get the work done. But the main thing is, what is the time period here? Okay, what is the time period? So that time period you need to understand from this expression itself, right? How to calculate the time period here? See everyone. So let us write the torque expression here first of all. T is given as 10,000. 10,000 plus 1000 sin 2 theta. Minus 1200 cos 2 theta. right? So this is the torque expression we are having. Now in this case, I've told you how to find out the time period. For sine 2 theta, time period will be 2 pi divided by 2. For cos 2 theta, it will be 2 pi by 2. So whenever we have this kind of time periods like 2 pi by 2, 2 pi by 2, it is there. So what we will do, we will take the LCM of the numerator and HCF of the denominator. Please understand, this is a very, very important point here, because in this case it is very easy to calculate the time period, but in some cases it will be what, different number you will be getting in the denominator, different number you will be getting in the LCM also. So at that time we have to be, okay, we have to be what, very careful while calculating those LCM and HCF, right? So the point here that you need to understand here is LCM, okay, of numerator and in the denominator is HCF of denominator, okay, right? So LCM of numerator will be 2 pi, okay. So if I consider this as 2 pi here, and HCF, please understand, LCM of 2 pi comma 2 pi divided by HCF of 2 comma 2, right? So finally if you solve, you will be getting pi is the answer. So pi will be the time period here. Pi will be considered as a time period, okay everyone. So why the time period calculation is very important? To calculate the work done per cycle, because as we know that after the time period cycle is going to repeat. So now the work done will be written as, everyone, work done per cycle will be written as T d theta 0 to time period, that is pi. Torque expression is there, we need to integrate it, okay. So let us write here 0 to pi, 10,000 plus 1000 sine 2 theta minus 1200 cos 2 theta, like this. Clear? So integration 0 to pi, pi will be our time period here. So 10,000 plus 100 sine 2 theta minus 1200 cos 2 theta and d theta it is there. Now integration we have to do. Now if I do the integration, what I will be getting here? It will be 10,000 multiplied by pi minus 0. Okay, so directly integrating and directly I am putting the limits also. Integration will be what? 10,000 into theta. If I put the limit pi 0 to pi, so it will be like this. So after integration, I am directly writing the limits also. Okay, so don't be confused. I've just skipped one step here. Okay, direct integration and also limit also I'm putting at the same time. Now it is 1000. Right, integration of sine 2 theta will be minus cos 2 theta, and here first of all we will be writing cos 2 pi. Then minus sign will be coming, but that minus becomes positive, so cos 0 it will be there, because limit was from 0 to pi, because as this is 2 theta, okay, so that's why here 2 pi comes. Now minus 1200, so cos 2 theta different, if I do the integration it will be sine 2 theta. So sine 2 pi minus sine 0, like this. So this is what the equation we are having. Now very important point, guys. Now sine 2 pi 0, sine 0 already 0, so it will get cancelled out. Okay, it is completely 0. Now cos 0 is 1, cos 0 is 1, and this is cos 2 pi, it is also 1, but with minus sign it will get cancelled out, 0. So finally the mean torque value that we are getting, okay, total work done, basically work done per cycle, answer. Please check everyone this part. Work done per cycle will be getting as 10,000 into pi. That is the work done we got per cycle. Per cycle, this is the work done we are getting. Clear? Now, in order to calculate the time period, as I already discussed here, see, time period calculation. This time period calculation will be what? Work done per cycle divided by time period. So using this relation, we will get the answer of time period, right? So work done per cycle 1000 pi, pi is our time period. So mean torque will be what? 10,000 value. So let us write here. Work done per cycle divided by time period, right? Now, mean torque will be 10,000 into pi divided by pi. So, Tm value we got as 10,000. Fine. Is that clear? Till this point, everyone, is there any doubt? Okay, if you are facing any confusion or any doubt, please ask in the live chat box. Okay. Right, so mean torque we got it, but the main point here is we need to calculate the power. Power calculation will be mean torque multiplied by omega. This 10,000 multiplied by omega. So omega, RPM they have given 100 RPM. So it will be 2 pi n, that is 100 RPM they have given, divided by 60. From this you will get the answer of power as well. I hope the approach is clear to everyone. Okay, how we came to this power? We have first calculated mean torque. In order to calculate mean torque, we have calculated work done per cycle. So from the work done per cycle we got mean torque, and from mean torque we got this power. So that's why we need to relate the different parameters here, right? So please do the calculation and tell me what will be your answer. Everyone, please do the calculation and tell me about your answers, guys. What will be your answer? Okay, I think options are given. No, options are not given. So this is a NET kind of problem, right? So approximately 104.7 kilowatt. kilowatt. This is the power we have solved here. This is the power we are getting after solving this power calculation part. After solving this basic calculation, we got 104.7 kilowatt as the answer. Is that clear? So very important point in this particular problem. First of all, in order to calculate power, mean torque requirement is there. Okay, so don't be confused that which kind of torque we need to put, max or mean. Okay, so always remember average torque, mean torque value we need to put here. RPM they've given, so we put that RPM only. But let's suppose no RPM they've mentioned at this RPM. So we need to calculate power at the mean RPM or the mean omega value, average omega value, right? As we have written average or the mean torque. So omega has to be what? Average. But here they have given omega, so directly we have used that omega part. So, okay, so please remember this point. And this formula I hope everyone will remember. Mean torque, work done per cycle divided by the time period. That is very easy. And what happens now? Most of the time while doing this integration, mistakes happens. So you have to be very careful while doing the integration part. While doing the integration part, you have to be very, very careful, because if you have done small mistake here, you will be getting wrong work done per cycle, and also the mean torque will also be wrong, and also then power will also be wrong. So please be careful while doing this integration part. If you are doing the integration part, be careful, okay, because chances of mistakes happens here. Mostly maximum chances will be here only. Maximum student do mistake here in the integration part, that I have seen. Okay, so be careful while doing such kind of integration. Now coming to the next numerical, guys, next numerical, everyone see. 2014 2 marks, they have given a flywheel whose mass m distributed almost equally between, now very important, we need to read this question very carefully. Okay, sometimes know what happens, we are in so much hurry, we read the question so fast that sometimes we will misinterpret the question language. Misinterpretation we will do. So that thing will only happen when we are in hurry. Okay, we read the question so fast. Read it, okay, read very, like, it should not be like in a very fast mood, okay, because if we read it very fast, some of the things we will miss, some of the information we will miss. Okay, so remember, you have to read it very peacefully. Okay, it should not be like we are reading fast and we will miss some data. That should not happen. Now consider a flywheel whose mass capital M is distributed. Okay, capital mass M is distributed almost equally. Equally it is distributed between heavy ring like rim of radius r. So there is one part heavy ring like rim of radius r and a concentric disc like feature of radius r by 2. This is a very important information. The mass of flywheel, that is capital M, is divided equally in two parts. The part one is the ring shape. Second part is concentric disc. Is it clear? Very important. Other parts of the flywheel such as spokes, etc. have negligible mass. So we don't need to consider those masses of the spokes. The best approximation of alpha value if the moment of inertia of the flywheel is expressed as alpha mr square. If mass moment of inertia is expressed as alpha mr square, what will be the value of alpha here? Right. First of all, if you have understood the question, draw the diagram immediately. Because if you have understood the question, it will be easy for you to draw the diagram, and then writing mass moment of inertia will also become very easy. Right. So first of all, we'll draw the diagram here. See everyone. Okay, so this is the ring shape. Okay, clear? So ring shape rim, okay, ring shape rim we are having radius r, and a concentric disc having a feature of radius r by 2. Okay, concentric disc like feature. Concentric disc will be like this. Now here we will fill this color. Fine. So this is the center point. So we have this spokes, let's suppose. Right, is it clear? I hope the diagram is clear, everyone. So ring shape is there and there is a concentric disc. Both are having same amount of mass. that is m by 2, m by 2. And other parts, that is spokes, is having negligible mass, so we don't consider spokes for the calculation of mass moment of inertia. Very basic point. Now, as they have mentioned, ki mass moment of inertia is mentioned as alpha mr square. Okay. So first of all, the mass moment of inertia value will be equals to there is ring shape plus there is a concentric disc. Ring plus concentric disc. Okay, fine. Now, if I talk about the ring, mr square, the formula is mr square. M r1 square, m into r1 square plus r2 square divided by 2. That formula we have written when we have two different radius, that is inner radius and outer radius is given for ring. But for in this case ring, they have given only one radius, right? Only radius r they have given. So we will consider that one. So formula of the ring will be mr square, but here mass of a ring will be m by 2 into r square. Okay, so this is for the ring we have written mass moment of inertia value. For the disc, formula is half mr square, half mr square. But for the disc, what is the mass? What is the mass value? M by 2 again, and r is what? R by 2. Now we will just simplify this relation and express as alpha mr square value, and basically whatever the resultant answer we are getting after simplification, whatever answer we are getting, we will compare it with alpha mr square and we'll get the answer of alpha. Very easily we will get the answer alpha, right? So we'll write here ring, we will have like this, m by 2. Right, everyone? So half mr square for the disc. So just simplify it, you will get the answer. This is m r square by 2 plus it will be m r square. So this will be 4 and 4 of 4, 16 it will be there. Correct? 2 square will be 4, 4 into 2 8 and 8 2 into 16, and this is what mr square by 2. Now in order to get same denominator, we will just multiply with the 8 numerator and denominator in the first expression. So we will get 8 mr square and this will be 9 mr square divided by 16, because denominator we have taken same, that is 16 we have make just by multiply 8 in the numerator and denominator here. So 8 to 16 it will be there, so and 8 mr square plus 1 mr square, 9 mr square. Finally we will do what? We will compare this value with the alpha mr square and we'll get the answer of alpha very easily. Okay, we will compare it with alpha. 9 mr square divided by 16. Okay, compare it with alpha mr square, alpha value you will be getting. So please do the calculation and tell me your answer. What will be the value of alpha you will get after this? Do the calculation and tell me your answers, everyone. What will be your answers, everyone? Tell me first. .562 will be the answer here. Okay, 0.562. 0.562 will be the answer here. So this question was a very important question they have given. Similar kind of question can be asked in different examinations also. So this is a very important question because only those students will be able to solve this question who knows clearly like what are the different formulas of mass moment of inertia. For ring, what is the mass moment of inertia formula? For disk, what is the mass moment of inertia formula? So if that mass moment of inertia relations, if you have remembered it, you will be able to get the answer very easily. Okay, and also if you have read it carefully and understood it and understood whatever they have mentioned in the question, then it is what simple calculation part. So that's why I am telling this is important if you have understood the concept of mass moment of inertia, right? So that mass moment of inertia concept is very important for mechanical students, right? I've seen ki many times area moment of inertia everyone will be able to remember, but mass moment of inertia many people will forget. For disk, for ring, okay, for sphere and for rod, for these cases you need to remember the mass moment of inertia value, right? Mass moment of inertia value you need to remember for such cases. Okay, not only in theory of machine but for engineering mechanics also it is important. Now done, this one is done. Now coming to the next question, guys. Okay, so GATE 2024, this question was asked in this GATE 2024 examination. Now read it very carefully again. Change in the kinetic energy delta E of an engine is 300 joule. Already delta E value they have given, and minimum and maximum shaft speeds are given 220 and 280 like that. Assume that the torque time function is purely harmonic to achieve a coefficient of fluctuation 0.05. Directly CS value they have given. CS value they have given directly. The moment of inertia of the flywheel to be mounted on the engine shaft is, again we will go to the basic formula of delta E. First of all, given data we will write here. What is the given data here? See, delta E value, joule, omega mean and omega max. Is it clear? Now, coefficient of fluctuation is 0.05. Okay. Moment of inertia they are asking. So we directly have this formula, na? Delta E equals to the mass moment of inertia Im omega square Cs. Omega will be omega average. Now when maximum and minimum values are given, we can calculate omega average. Cs already given in the question directly. Delta E is also given. So mass moment of inertia will be what? Very easy. See, such kind of sample questions also asked in 2 marks. So that's what I'm telling ki such kind of questions are very easy. So don't be afraid, okay, ki like in the GATE examinations more difficult questions will be asked. No, questions will be easy if you have a clear understanding of the concepts. So please understand, once you have understood, you have learned any topic, make sure that you will solve at least all PYQ from that topic. Without solving numerical, I can guarantee you never you will be able to understand the topic completely, because after reading a theoretical part you might have a feeling that I have understood it, but while during the implementation part or execution part, that is when we are solving numericals, you will face some difficulties, or if you have not understood it completely you will not be able to solve the numericals. So that's why whenever you want to check whether you have understood a topic or not, just try and solve questions from that particular topic. That questions might be from your previous year GATE question, test series or exercise book that IMS GATE Academy is giving here. So practicing numerical is must. Please understand this point. Without practicing numerical, you will never gain the confidence. Okay, so in the GATE examination, your rank is totally proportional to how much extra practice, extra numerical practice, I will be specific here regarding practice, extra numerical practice here I'm talking about. How much extra numerical practice anyone has done. So that extra numerical practice will give you the confidence, and that confidence will definitely help you to get a very good rank in the GATE examination. So that's why your focus, if your target is GATE examination, your focus should be on solving more different variety of questions apart from GATE PYQ. Once it is done GATE PYQ, it's not like you have done completely everything. There are so many other source of questions also. Exercise book questions are there. Okay, online test series is there. You can solve engineering services prelims questions also. If you have time, you can solve engineering services conventional questions also. So more and more different variety of questions when you are trying to solve, more clarity you will be having regarding that particular topic. So that's why I'm telling solving more question is what very important thing, where actually many students are lacking. That I have seen personally, that student have understood the topic, they have learned everything, they have solved 1 or 2 PYQ questions also, and they will feel that is okay, that is more than sufficient for the GATE examination. But that is not more than sufficient. It is actually less if I compare to what is required is for the GATE examination. You are doing very less compared to the what is required for GATE. Nowadays standard is very high in the GATE examination. Questions are every year new, different variety of questions are coming. You can't just solve previous year question and go for the GATE examination and think you will get very good score. No, it's not possible. Simply solving GATE PYQ will not help you to get a very good score. Yes, definitely it will help you to get a decent score, but not a very good score. For that, for getting a very good score, you need to invest more time on numerical solving. I hope this point is clear to everyone. Okay, so we were discussing regarding this 24 problem, GATE 2024. So that was the formula, okay, right? This is the formula we need to use. So if I use that formula, delta E value 300, mass moment of inertia we need to calculate, omega average is what? Mean plus maximum, minimum value plus maximum value divided by 2. So that is 220 plus 280. So from here, mass moment of inertia value you will be getting. Okay, so this part you should remember. Omega average will be written as omega minimum, omega maximum divided by 2. Right? And if I talk about CS formula that we have discussed already in the previous class, maximum omega minus minimum omega divided by omega average. Right? So CS formula. So max minus minimum is what? The range. Whenever we take a difference from max to minimum value, we will call it as a range divided by the average. So instead of writing omega also, we can use RPM here. Right? So these are the formulas that we need to remember it. So what would be your answer here after doing this calculation part, guys? What would be your answer? A, B, C, D. Any options? Any of the options from this out of 4, which options will be correct? Which option basically? Right? So see, it's a very basic question. Okay. From the flywheel, I'm in the starting only I've told you, flywheel is a very scoring topic in the GATE examination. If you have understood the topic, understand everything regarding the basic or the fundamental part of a flywheel, understood how parameters we can relate different parameters with each other, what is fluctuation of energy, what is work done per cycle, all those things you have understood, and if you have solved previous year question, then flywheel is a very scoring topic for you. You can easily score a very good marks in this flywheel topic. Okay, so if you solve here, finally you will be getting approximately 0.096 kg meter square. So if you see the option B will be the correct answer here. Right, now moving to the next question, guys. This one again. See, GATE 2014 this time, maximum fluctuation of a kinetic energy in an engine has been calculated to be 2600 joule. Okay, delta E value they have given. Assuming that the engine runs at an average speed of 200 rpm, omega or n average they have given because it is an rpm. Polar mass moment of inertia, okay, of a flywheel to keep the speed fluctuation within plus minus 0.5% of the average speed is. So mass moment of inertia, basically they are saying what is the mass moment of inertia you will calculate. Okay, what is the mass moment of inertia value required here. Now again here, first of all write the data, given data. So if I write the given data, first of all delta E value 2600 joule. Okay, average speed, that is n average, (200 rpm). Mass moment of inertia they are asking. Now CS value plus minus 0.5%. Now plus minus 0.5% is actually equal to 1% because it is saying from minus 0.5 to plus 0.5. So if I write complete in terms of magnitude, if I talk about, it will be equal to 1%. Okay, so you don't need to confuse here whether I have to take 0.5% or 0.1%. We have to take it as a 1% here because 0.5 plus 0.5 it is equals to 1% here. So finally it is equal to 1%. So the value will be equals to 0.01 because the value that we have to consider here is from minus 0.5% to plus 0.5%. Clear everyone? Okay, right. Now all the data is given, just put the values here in the question, you will get the answer very easily. I omega square, omega average square into CS, delta E value 2600. Mass moment of inertia, omega average, n average 200 rpm it is given, so 2 pi n into 200, 2 pi n by 60. So from here you will get the answer of mass moment of inertia. Right? Okay. Do it fast, guys, the calculation part. So as we have seen so many GATE previous year problems from the flywheel topic, I hope now you got the confidence in the flywheel topic, right? Because almost every question we have discussed and we have seen how to approach such kind of problems from the flywheel topic. And one interesting thing you will notice here कि most of the questions are similar only, right? Mostly sometimes they will ask calculate the mass moment of inertia value of the flywheel required. Sometimes mass of the flywheel required. Such kind of questions they will be asking. So more or less mostly questions will be similar. So that's why I'm telling this is the most scoring topic of theory of machine. So you should not miss this particular topic for your GATE examination. Done everyone? So answer that I am having here is 592.9 after solving this one. 592.9 kg meter square. That is what the answer of mass moment of inertia. Okay, and I hope we have discussed also, I think, regarding how to write mass moment of inertia in a different way using radius of gyration. Yes or no? The mass moment of inertia value will be written as m multiplied by k square. K is what? Radius of gyration. So sometimes they will not ask this mass moment of inertia. They will be asking radius of gyration, right? So radius of gyration, it will be given in the question. M is simply the mass. K radius of gyration. Is it clear? Now, so let's suppose sometimes, for example here, what is the radius of gyration for the disk? So let's suppose there is a disk we are having. So at the center point, we know that mass moment of inertia value will be written as mr square by 2. Now mass moment of inertia value we understood here, this formula. But let's suppose if I want to know the radius of gyration value. If I want to know the radius of gyration value, so what I will do? Simply whatever the mass moment of inertia value we know, simply we will equate it with mk square. That's all we need to do. We will equate whatever the formula we are having for this mass moment of inertia, we will equate with mk square. And from that k value we are getting, that is what radius of gyration here. So just equate with mk square here. M will get cancelled out, so k value you will be getting as approximately r by root 2. So using this you will get the radius of gyration. So for this disk, radius of gyration is r by root 2. Is it clear everyone? Yes or no? Please tell me. Done? So for disk I find out, for other particular cases also you can find out this kind of radius of gyration if we know the value of mass moment of inertia. If mass moment of inertia value is known to us, we can easily calculate radius of gyration. Okay, so this value belongs to what? Radius of gyration. Radius of gyration for disk. Done. Now moving to the next numerical. Yes, this one. Now this is somewhat different variety of problem. In this case, torque expression they have not given. Directly they have provided T theta diagram. Okay. Now see, turning moment diagram of a flywheel fitted to a fictitious engine is shown in figure. Okay. Mean turning moment is 2000 Newton meter. So this is the important information they have given. Mean torque value they have given as 2000 Newton meter. The average engine speed 1000 rpm. Okay, for fluctuation of speed to be within plus minus 2%, plus minus 2%. So in actual it is 4%, plus minus 2% they have mentioned, it is actually 4% of the average speed. The mass moment of inertia of the flywheel is, okay, so mean torque is given, right? Omega average is also given. The question is regarding the mass moment of inertia. So whenever mass moment of inertia they will talk about, we will use this formula. Like this, I omega square into Cs. This is the formula we are having. Now main question here is how to calculate this delta E. Problem here is delta E calculation. How to get delta E? Because if a delta E value is known to us, then calculation of mass moment of inertia of flywheel is very easy basically. We have seen in previous problem also. In previous problem we have understood like how to calculate mass moment of inertia. If delta E value is given, then directly I will use this formula. If I use formula this formula if I use, delta E value is given. So mass moment of inertia is very easy to calculate, very easy. Now how to get delta E? So I hope you remember there is a point, okay. Delta E is the fluctuation of energy, right? Fluctuation you will see above the mean torque. Now the mean torque 2000 already they have given to us, 2000 value already given to us. Now fluctuation if you observe here, above this mean torque value is this much. Now this is also a kind of fluctuation, but here we need to take the maximum fluctuation. So maximum fluctuations will be for this one. So this area will be equal to delta E. That area will be equal to delta E, excess energy. Or we can simply mention delta E max. Is that clear everyone? So delta E max value from this diagram we can easily calculate, okay. Using that delta E max value here, we will get the answer of mass moment of inertia as well. Mass moment of inertia value also we will be able to calculate. So this is 3000. Okay, so let us write here first of all. This is 3000, this much length is 3000, it is there, and this is pi minus pi by 2. Pi minus pi by 2, that is there, okay. So this is 3000, this is 2000, okay. Remember this point also, 3000 minus 2000, so this much length will be getting, and the difference this much. If I multiply, I will get the total delta E answer. 3000 minus 2000 multiplied by pi minus pi by 2. Pi minus pi by 2. Clear? So from here delta E answer we will be able to get. That delta E value I will put it here. Directly this delta E value I will put here, and I will get the answer of mass moment of inertia. So now please everyone calculate the answer and mention your answer in the chat box. Everyone, fast, do it. I've told you the approach, now it becomes very easy for you. You can easily solve this question. Okay, now the question become very easy. Right. So delta E calculation, I hope everyone has understood how we have solved the delta E. Right. Sometimes in the question it will be given, but now in this case, instead of giving directly the value of delta E, they have given some diagram, T theta diagram they have given. From that also we can calculate delta E value. So like that we have calculated, use this value equal to this one, you will get the answer of mass moment of inertia. Is it clear everyone? Put the values here and tell me your answers. Okay. So this plus minus 2%, plus minus 2% is equivalent to 4%. Okay, so that point you should not forget. Okay. So from here, the mass moment of inertia value approximately 3.58 kg meter square. So please cross check also everyone. This data, this information you should cross check. Right, 3.58 kg meter square. Done everyone. So we have almost solved all different variety of problems. Now in the next session, punching problem we are going to discuss with complete theoretical aspect also, the working of that punching machine, what are those important parameters that we need to understand, and we will try to solve some punching problems. So actually those punching problems were from the engineering services conventional examination. So chances are there that those kind of questions might come in your gate examination also, or similar to that kind. So that's why punching problem also we need to do it, right? So in the next sessions, our target will be what? We will understand first of all punching machine, all the parameters, and then we will solve it. Okay, questions related to that one, which was as in engineering services conventional, right? So I hope you have understood all the questions that we have discussed today in Flywheel chapter, and tomorrow will be the last session of the Flywheel, and after that gears we are going to start. Okay, where we'll be discussing first basic classifications, and then we'll go to terminology, and then gate train directly we are going to start, which is very, very important for your gate examination. And I will teach you the shortcut method in gate train, that is relative velocity method, right? So thank you so much guys, and stay tuned to this IMS Gate Academy YouTube channel. Lot of upcoming videos will be coming here. So always subscribe to this IMS Gate Academy YouTube channel, and if you are liking this our foundation course, specifically if I talk about this theory of machine, so please share this session to your friends as well, right? So thank you so much guys. We'll meet you tomorrow again same timing for the Flywheel last topic that is punching we are going to discuss. Okay, thank you so much. Bye bye.